Hello class, today we'll be doing your guided lab 9 for IS 2010. To find this assignment, please go to your week 13 module and select guided lab 9. For this lab, we'll be going over these skills. We'll be doing classic probability, principles accounting, empirical probability, and subject probability. Hey, let's go ahead and begin. Go ahead and download your file. I already downloaded mine, so let me go ahead and open it up. Make sure you have enabled editing, and then we're going to save the file real fast. So save as, browse. Okay, ready to begin. Let's go ahead and go to our Classic 1 worksheet. Let's go ahead and read what we have to do. For scenario 1, we want to go ahead and enter each possible outcome for a 12-sided die through cells A4 through A15. Okay, so let's go ahead and do that. So we start with 1, 2, 3. We can highlight our cells and then drag all the way down to 12. Okay. Next thing, we want to select cell B4 and type in the formula for classical probability for the 12-sided die. So for each one of these possibilities, it is equal to 1 divided by 12. Go ahead and just drag this all the way down, and we should get a probability of 1 at the bottom for the sum, and each one should be 0.083 for the probability. Okay, next thing we want to do is that we want to randomize our rolls for how many times they're going to either land on these outcomes. So let's go ahead and do our rand function. So equals rand between, and we want to have a random in between from 1 and 12 for the dice. And then next thing we want to do is that we're going to go ahead and press enter. Go ahead and drag this down. Oops, there we go. Okay, we should see now that we have our randomized rolls right here, and we could press F9 to keep randomizing as well if we want to. Okay, next in cell D4, we want to go ahead and create a total here, a score, and the score is by your die outcome by how many rolls. So this is equal to the die outcome times by the number of rolls. So C4. So 1 times 10 is equal to 10, that's good. And we don't need to do referencing here since we want it to be filled for the rest. And we should see here that this is consistent, so 12 times 2 is equal to 24, so that's good. Okay, for the last part of this chart that we're going to be filling is we need to figure out the relative frequency based on the number of rolls we have. So let's go ahead and do that. So we're going to do equals our number of rolls divided by our total amount of rolls. We want to go ahead and absolute this. And then next thing we want to do is that we want to go ahead and drag this all the way down so that our total frequency is 1, which should be correct because this encompasses all the total number of rolls that we want to have. And we see here that each one's going to have their own distinct frequency. Okay, next we want to do for this worksheet is that we want to visualize this. So let's go ahead and make a bar chart. So go ahead and highlight your cells E3 through E15. Go to insert. I'm going to create a bar chart right here. Bar chart right here, 2D bar. Go. Next thing we want to do, we can just stylize this however we want. So I'm going to choose this one right here. And then one thing we could do, press F9. We can see that these values are going to be changing every time we press F9. Okay, that's it for scenario 1, classical 1 worksheet. So let's move on to classical 2 worksheet. Okay. We're starting off with, we need to create probabilities of each one of these different size of shirts to possibly be chosen by customers. So to do this, I'm going to do equals 1. And then I am going to have 4 here, so I can just do 1 divided by 4. Or something else I can do as well is use the count A function, where it counts how many cells have been filled out. So I'm just going to do that. And we're going to have a 0.25, and before we bring it down, I'm going to go ahead and absolute it, just like that, and go ahead and drag. We should get a total of 1, which is correct because we have 4 different items. Probability is 0.25, and it's the same for the rest because there's only 4 options. Okay, Want to go ahead and insert a pie chart, so let's go and do that. Select cells A3 through A7, go to insert. I'm going to insert our pie chart now, which should look like this. Just a 4-way split chart, and we go ahead and style it if we want. Now, the next thing we want to do is that we want to add in a 5th item, and this 5th item is going to be an extra large to the table. To do this, we're just going to go ahead and add a new row. So I'm going to add it, I believe, right here. Not, there we go, yep. And then we're going to call this extra, oops, click on the cell, extra dash large. And then we're going to go ahead and drag this formula down. Oh, actually, we got to change this now to encompass A8. This one, B7. This one also needs to encompass B8. Now we can drag this all the way down, just like that. Then we can change this pie chart to include our 5th one. There we go. So this is what your pie chart should look like. And this should be it for worksheet 2. Okay, moving on for principles accounting. We're going to be doing some math here. So let's answer question 1. Let's say we roll 4 10-sided dice. How many total possible outcomes are there? Well, each dice has 10 different combinations. 10 different outcomes because it's a 10-sided die, but we have 4 of them. So this would be simply as us just doing 10 to the power of 4. Oops, let me go ahead and make that an equal sign. There we go. So we should have 10,000 different outcomes for a 10-sided die. Okay, moving on, we want to answer this permutation question. A company is selected 3 managers to lead 3 new international branches, 1 in Tokyo, 1 in Paris, and 1 in New York. The managers will be chosen from a group of 6 qualified employees, and each city must have a different manager. Okay, the key importance here is that each city must have a different manager. How many different ways can the company assign the managers to the branches? Okay, so we are going to be using factorials here to help us out. So first thing we want to do is we want to start out with creating a factorial function. So go ahead and use equals fact. And then we are going to have the total outcome that we can have from 6 different combinations of employees. So we have factorial of 6. And then from here, the last step we want to do is that we have another factorial divided by number of qualified members and the number of different branches that we need to assign them. And we're going to have 6 minus 3. And this right here, we'll factor in that the managers will be each unique and they will not be repeating, or else that would mess up with this calculation. So go ahead and make sure it says this, fact 6 divided by fact 6 minus 3. Go ahead and press enter, and we should have 120 different combinations of employing these 6 employees to the 3 branches. Okay, next one we have here is that we have a combination question. So a company is forming a project team of 4 employees from a department of 10 people. The team members will have all equal roles, and the order in which they are selected does not matter. How many different ways can the company form the project team? So this is going to be very similar to what we have above. So we're going to start with the total of there being 10 people. So equals factorial, but fact. And then we're going to have 10 people. And in this case, it's going to be slightly different. Ordering does not matter in this case. So we're going to start out with a factorial of 4. And then we're going to times this result by the factorial of there only being able to be 10 minus factorial 10 minus 6, so minus 6, just like that. Okay, go ahead and press enter, and there should be 210 different possibilities. Oops, so I went wrong here. Fact 4 times by fact 10 minus, oops, my bad, this should be 4, my bad. There you go. So 210 is your answer. Now, to go into what a factorial is, if you don't know what it is, so let's say we want to take the factorial of 6, so equals fact 6. This is just equals to 5 times 6 times 5 times 4 times 3 times 2 times 1. That is what factorial is doing. So rather than writing this all out, we are instead just condensing it down to a formula for Excel to do for us. Okay. On to the last step, we want to go ahead and create an empirical probability. Let's go ahead and enter in these product categories and units sold. So I'm going to start with something easy, 500, 300, 800, whoops, 200, and then we have 100 here. Next thing we have is electronics. This one is clothing, groceries, home decor, and toys. There we go. Okay, next thing we want to do is that we want to calculate the empirical probability. And this should be very familiar to us because all it is just using frequency distribution. So we're going to be starting with the units sold divided by our total, and we're going to absolute that last part. Go ahead and drag all the way down. And now we want to go ahead for the final part is just visualize this. So let's go ahead and do that. Insert a bar chart, just like this. And I'm going to choose any style I want. And we can go ahead and will be the end of our lab. A very quick lab today, so let's go ahead and submit it. So I'm going to close this. Going to go ahead and go do this. Whoops, choose a file, show all files. Okay, and just like that, our lab is complete. I hope you guys followed along just fine. If you have any questions, go ahead and email your professor or TA for help. And hope you guys have a great day.